We now discuss the solution of a problem from the section coordinate geometry. This given question is on hyperbola, using the concepts of eccentricity, normal to the hyperbola at a given point. This question has appeared in the joint entrance examination main held on 25th June 2022 in the second shift. The given question is, let the eccentricity of the hyperbola x square by a square minus y square by b square is equal to 1 be 5 by 4. If the equation of the normal at the point 8 by root 5, 12 by 5 on the hyperbola is 8 times root 5x plus beta y is equal to lambda, then lambda minus beta is equal to. It is given the eccentricity of this parabola, of this hyperbola, x square by a square minus y square by b square is equal to 1 is given to be 5 by 4. It is further given the normal at this point 8 by root 5, 12 by 5 on the hyperbola, on this given hyperbola is 8 root 5x plus beta y is equal to lambda, required to find the value of lambda minus beta. That is our given question. We now discuss the solution of the problem in detail. Let's call the hyperbola as h, whose equation is x square by a square minus y square by b square is equal to 1. Given its eccentricity E is equal to 5 by 4. We recall a formula, that is b square is equal to a square times e square minus 1. Substitute the value of e in this, that is b square is equal to a square times e square 5 by 4 whole square minus 1. On simplification, you will get 9 by 16 a square. So that's the relationship between b and a. It is given the point, let's call it as capital A, whose coordinates are 8 by root 5, 12 by 5. It is given A is on H, therefore the coordinates of A must satisfy the equation of the hyperbola. So substituting in the equation of the hyperbola, for x 8 by root 5 and for y 12 by 5, we get this. Now simplifying, we will get 64 by 5a square minus 144 by 25 into 1 by b square. 1 by b square is 16 by 9a square is equal to 1. Simplify and we get 320 minus 256 is equal to 25a square. That will imply 25a square is equal to 64. A square is equal to 64 by 25. So we will now write down what is b square. B square is equal to 9 by 16 a square. A square value we know. Substitute. We will get b square is equal to 9 by 16 a square. The a square is 64 by 25. So on simplification, 16 1s are 16, 4s are 4, 9s are 36 by 25. So b square is equal to 36 by 25. Thus we got a square, we got b square. That means the hyperbola is completely known to us. We have the hyperbola h. A square is equal to 64 by 25. B square is equal to 36 by 25. Brought forward from the last slide. Now the equation of the normal at a point x1, y1 on h. Let's recall the formula a square x by x1 plus b square y by y1 is equal to a square plus b square at the point x1, y1 on H. But now the equation of the normal at A, whose coordinates are 8 by root 5, 12 by 5 on H. So substituting for x1 is equal to 8 by root 5, y1 is equal to 12 by 5, and a square is equal to 64 by 25, b square is equal to 36 by 25. In the normal equation, we get this one. We get this. So we get a square 64 by 25 into by x1, that is root 5 by 8x, etc. We get this one. So on simplification, so 8 ones are 8, 8 8s are 64, and here 12 ones are 12, 12 3s are 36. Then you will get this equation, and taking the LCM, then you will get 8 root 5x plus 15y is equal to 100. That is the equation of the normal at the point A, whose coordinates are 8 by root 5, 12 by 5. And this is the equation 1. That's the normal at A on H. But it is given in the question. The normal at A on H is 8 root 5x plus beta y is equal to lambda. Let's call this as the equation 2. Equation 1 and equation 2 is one and the same. Therefore, comparing the equations 1 and 2, we get beta is equal to 15, lambda is equal to 100. What is that we want? We want to find the value of lambda minus beta. Lambda minus beta is equal to, lambda is 100 minus beta is 15, that is 85. So that is the detailed discussion of the solution of the problem on hyperbola, which uses the concepts of eccentricity and the equation of the normal at a given point on the hyperbola. And it is a straightforward question which uses only two formulas. I am sure that you have understood the solution of this problem. I wish you all the best. Thank you.